Hello friends, this is solution of paper C-10 analog system and applications physics BSc physics 4th semester Dibrugarh University 2022. So this is part 2. In part 1 we have solved up to question number 4 and in this video we're going to solve up to question in this video we're going to solve from question number 5. Before we start, please subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you. Okay, so now let's start. And one more thing, this is my Insta ID, Oza Loikhajit 123. You can follow me on Insta. Okay, so now let's start. So this is question number 5. Draw a voltage divider by a circuit and derive an expression for its stability factor. Okay, so let me give you the answer here. So this is the 5A answer. So it starts from here. Take the screenshot, and this is the next slide. Take the screenshot. Okay, so here the next, then this one, this is the last. Okay, this is the last slide. So now let's move on to the next question. So here is another question. Either you have to answer this question or you have to solve this problem. So here germanium transistor with beta is equal to 100 is to be operated as CE amplifier with fixed bias method. The transistor operates at the signal collector current. This is 1 milliampere. VCE is 4 volt. If a load resistance of 20 kilowatt is connected in the collector circuit, then find the base resistance to be connected. Okay, so what is the base resistance to be connected? That is RB, that has to be determined here. And here load resistance is given. Load resistance is given here, that is RC. RC is given 2 kilo ohm. Okay, so let's solve this question. Okay, so first let me mention what are the information given here in the question, in the problem. So 5A, the question which is optional question, or the numerical is given here. So beta is equal to 100, IC is equal to 1 milliampere. So let me convert it into ampere. That's going to be 10 to the power minus 3 ampere. Okay, so and also let me find IB, and IB is equal to IC by beta. Okay, so IC is 10 to the power minus 3 by beta is 100, so that's going to be 10 to the power minus 5 ampere, right? So now also here it is given VCE 4 volt and RC load resistance is 2 kilo ohm. So that's going to be 2 into 10 to the power 3 ohm, right? Then we need to find RB, right, base resistance. Then here VB is given, base emitter voltage 3 volt, right? Then in order to calculate RP, we must know VCC minus VB by IB. So here VCC is not given, which has to be calculated here. First let me find VCC. Remember this relation, which is equal to VCE minus, sorry, not minus, IC into RC. Okay, remember this relation. Then VC is 4 volt here. This is 4 volt plus IC. IC is 10 to the power minus 3. Then RC is 2 into 10 to the power plus 3. 2 into 10 to the power plus 3. So here 10 to the power plus 3 minus 3. So that's going to be 10 to the power 0. That's going to be 1. So we have 4 plus 2. That's going to be 6 volt. So VCC is 6 volt. So here therefore we can say RB. So let me just clean it. RB, which is equal to VCC minus VBE divided by IB. So that's going to be equal to 6 volt minus VBE is here 0.3 volt divided by IB. IB is 10 to the power minus 5. 10 to the power minus 5. Okay. So this must ohm. So here it's going to be equal to 5.7 by 10 to the it can be written 10 to the power plus 5 ohm, and here you see. So if you this is here 10 to the power 5 means 10 to the power 3 into 10 to the power 2, you can say. Okay, 10 to the power 2. If you multiply 10 to the power 2 with this one, that's going to be 570, right? And 10 to the power 3 is there, so that's why you can write 10 to the power 3 ohm. So 570 into 10 to the power 3 ohm means you can say 570 kilo ohm. That's what you can say, right? So hope you have understood this. So this is the answer. Okay, so now let's move on to the next question. Please take the screenshot. So 5B, draw the small signal hybrid equivalent circuit of a common emitter transistor amplifier. Derive the expression for the current gain input impedance. Okay, so let me give you the answer. Now you see in this part this part, draw a small signal hybrid equivalent circuit of common emitter transistor amplifier. I have done this one in 2023 paper C-10. In that paper also this question was asked, same question number 5B. Okay, so here only different thing is it is derive the expression for current gain and input impedance. So let me give you the expressions here. Okay, I'm not going to show the diagram. This small signal hybrid equivalent circuit, that is already done in 2023 paper. Now we are doing 2022 paper. Okay, 2023 is already done. Okay, if you check the question number 5B, if you have noted those answers of 2023, then you can find the answer in the same question number. Okay, so now let me show you that expression, those expressions current gain and input. First you know this parameters, H parameters. Okay, right, for this common base transistor. For this case here you see input impedance, the general expression is this one. So if you replace these terms, corresponding terms, by these terms, so then you're gonna get this relation. Similarly, the current gain, its general expression is this. So similarly, if you replace those general terms by this notations for CB, then you're gonna get this expression, right? So now let's move on to the next question. 5B, there is another question. Either you need to solve this one or this one. So let me answer this question as well. So let me go to the blank slide. This is the answer for question number 5B, or there were two questions. Okay, either you have to solve the first one or this one. So this is the answer to that question, or part, this one. Let me show you. So here, this part, explain class A, class B and class C amplifiers. So here is the answer. This is class A, and here you see this is class B. So just take the screenshot. This is the first slide, this is the second, and let me go to the next slide. So here is the last slide. This is class C amplifier. Okay, take the screenshot. So hope you have taken this. Okay, so now let's move on to the next question. Now question number 6, draw and discuss the frequency response curve RC coupled transistor amplifier showing the cutoff frequency and the bandwidth. So let me show that answer. So here is the answer of question number 6, frequency response curve, this one. So these two are the cutoff frequencies here, and this is the bandwidth. Okay, so hope you have understood this. Take the screenshot. Okay, so here is the bandwidth, you can write. bandwidth. Just wait, let me write it. This is bandwidth. So take the screenshot. Now let's move on to question number 7. Question number 7, discuss the effect of negative feedback and the input and output impedances and amplifier of an amplifier. So let me give you the answer. So this is the answer to the next question, question number 7 answer. Okay. So this is what effect of negative feedback on stability. This is the question number 7. Discuss the effect of negative feedback on input and output impedances of an amplifier. So here is the answer. Here you can see this. Effect of negative feedback on on input impedance. This is the first one, on input impedance. Okay, take the screenshot. So continue, take the screenshot, and on output impedance, this is the number 2. Okay, so now let's move on to next question. So this is the question number 8. State Barkhausen's criterion and explain the conditions that must be satisfied for feedback amplifier to produce steady oscillations. So let me give you the answer. So here is question number 8 answer. Okay, take the screenshot. Now let me go to the next slide. So here is the next slide, and this is the last slide. So take the screenshot of each slide. Okay, now let's move on to next question. 8, there is another question in 8, or this one. Either you have to solve this one or this one. Draw a circuit diagram of RC phase shift oscillator and explain the operation. So we're gonna continue solving this paper in the next video. Okay, thank you for watching. See you in the next video. Stay connected. Okay, and also press the bell icon so that you get notified when new video will be uploaded. See you in the next video. Bye bye.